Welcome back. I want to take a few minutes to recap the rules for exponents. I know you already know these, but we want to get them into our notes so that we can use them. We need to be very proficient at these. First rule, or multiplication law, is that when you're multiplying powers of the same base, you actually add the exponents. So here, this is very general. X to the a times x to the b equals x to the a plus b. Now hopefully we know what a and b are. Like in this example, x squared times x to the third is going to be x to the fifth. I can expand that for you so you can see what's actually happening here. X squared is x times x. X to the third is x times x times x. When I combine those all through multiplication, you can see that I end up with 5 factors of x. Shortcut, add the exponents right there. The next law we're looking at is the division law, which says if you are dividing powers of the same base, you subtract the exponents. And so here, once again, we have x to the a divided by x to the b is going to be x to the a minus b. And of course, hopefully we know a and b. So let's just pretend we have x to the 7th divided by x to the 4th. That's going to be x to the 3rd. So if, again, I wanted to expand that out like I did in the first example, x to the 7th would be 7 factors of x in the numerator divided by x to the 4th. And then what you have here are fractions of 1. And so for each x divided by x, I'm going to have a fraction of 1. So I can start crossing out and canceling out those fractions. X divided by x, x divided by x. Those go in 4 times. What we're left with then is 3 factors of x. And that's where the x cubed comes from. Okay. The power law is next. Power law says if we take an exponent, such as x to the a power, and raise it to the b power, we're going to multiply those two exponents together to give us x to the a times b. So in practice, x to the 4th squared would be x to the 8th. Keep in mind, x to the 4th is our base. So x to the 4th squared means x to the 4th 2 times. X to the 4th times x to the 4th. Now what I could do is kick in my rule for multiplication. Multiplying powers of the same base, we add the exponents. X to the 4th is here, times another x to the 4th is here, which will give us a final answer of x to the 8th. Now we don't expand them out like this, we use our shortcut rules, but this hopefully, if you're having trouble seeing what's going on, this will hopefully help you to wrap your mind around that rule or shortcut. The next rule is the 0 exponent rule. Anything to the 0 power is 1, always. I can show you why. Because if I know that x to the 4th divided by x to the 4th is equal to 1, anything divided by itself is always equal to 1. I can also look at it this way. Through the division rule, x to the 4th divided by x to the 4th would give me x to the 4 minus 4, which is x to the 0. But I already know it's equal to 1. And so if these are truly going to be equal to each other, then the definition says anything to the 0 power or x to the 0 power must be 1. Again, it doesn't matter what the base is. Here's 3 different examples. And again, keep in mind, what's the base? On this first example, 3x to the 0 here, right here, 3x is the base. This entire thing is raised to the 0 power. So this is actually equal to 1. Same thing here with the second example. X plus 4 is the binomial base raised to the 0 power. The answer is 1. However, on this third example, the base is just the x. Notice it's not in parentheses like this first example. And so this is technically 6 times 1, and your answer here will be 6. Just don't get pulled into some of the trickier questions. You need to watch the base. The base is always simply the number immediately to the left of the exponent. Okay. Okay, the next rule is the negative exponent rule. And we learned in class today, or let's see, Tuesday it would have been, when we were graphing the exponential, that negative exponent meant to reciprocate the base. And it's really important to remember that. So when you're looking here, this says x to the negative a is equal to 1 over x to the a, which is the same as 1 over x to the a, because that 1 to any power is just 1. So 3 to the negative 2 is going to equal 1 over 3 squared, which is 1/9. Okay, again, the negative in the exponent, if you can evaluate 3 squared, the negative just says 1 over. Also, over here, what this is trying to tell you is that if you have a fraction, we'll call it x over y, and you're raising it to a negative exponent, the negative will reciprocate the base. I don't like to do 1 over x over y because that's complex, that's nasty. So rather than doing that, we're just going to turn x over y into y over x and remove the negative from the exponent. Reciprocate the base, that's the key. Okay, so I'm going to put a little star right here. Reciprocate the base. So let me give you something like this. Here's an example. 2 thirds to the negative second power. So what I'm going to do is first reciprocate the base, make it 3 halves, and then I will square 3 halves. And that will take me to 9/4. Now, here's the beauty. Your calculator will do this. Just remember, the key is to place fractions in parentheses. Otherwise, it's not going to work for you. Okay, so anytime you have a fraction, whether it's a fractional base or in the next example, a fractional exponent, please make sure you put it in parentheses. Excuse me. Okay, let's see. Fractional exponent is brand new. I realize that. What you need to realize is when you have a fractional exponent, and the example here is showing you x to the a over b. What you want to remember is that the numerator is the power, the denominator is the root. It's easy to remember because the power is in the top and the root is in the bottom, just like a tree. Okay, so this example here, 8 to the 2 thirds, I would read that, you could read this as 8 squared cube rooted, or the cube root of 8 squared. You can write it like this as a radical, and sometimes that's the task. And the cube root of 8, of course, is 2, and 2 squared is 4. Now your calculator will do this. As long as, again, you put that fractional exponent in parentheses. Of course, if you have the newer 84s, once you go into the exponent, it keeps you in the exponent until you arrow out. So there's not as much of an issue with that. But the older models of 84 and the 83s, you need to make sure you have those parentheses. What this is saying here is that it does not matter if you do the power first or the root first. They're on the same level of order of operations, so it's irrelevant. So let me give you another example here. Let's say I take 16 to the 3 halves power. Now again, this here is a square root. That's what that means. And this piece here is a cube, or a power of 3. So if I take my 16 and I square root it, and then cube it, I will get, of course, square root of 16 is 4, and 4 cubed means 4 times 4 times 4, which is 64. Final answer. Okay. Another example. I can take, excuse me, let's do 8 to the 5 thirds power. Okay, so again, this is the root number. So it's going to be a cube root of 8 raised then to the 5th power. because this is the power. Cube root of 8 is 2, and 2 to the 5th is 32. Now these are not an issue, especially if it's numerical base and a numerical exponent, because you can just use your calculator all the time. And again, in your calculator, you're going to say 8 raised to the 5/3, and that will tell you 32. Okay, so ultimately what we're working towards are problems like these, where we have to express this in simplest form. And so one of the things that you need to do is remember the rules. And the three main rules right now are multiplying powers of the same base, add the exponents, divide powers of the same base, subtract the exponents, and taking powers to powers, you multiply the exponents. Keep in mind that when you have a numerical number, that's just a coefficient, leading coefficient squared, that does not behave the same way as an exponent behaves. Okay? So the first thing that I'm going to do here is suggest that you clear these parentheses and square everything inside the parentheses. I think the key to simplifying these is not going too fast, one step at a time. So when I square everything in that numerator, 4 squared, of course, is 16. X squared squared means 2 factors of x squared, which is x to the 4th. And y cubed squared, again, is y to the 6th. When we take a power to a power, we multiply the exponents. The denominator is already simple, and so we're just going to carry it through. Now, what I would do is my division piece, which says when you're dividing powers of the same base, you subtract the exponents. 16 divided by 2, of course, those are the coefficients, and that's just 8. X to the 4th divided by x to the 3rd, you're going to subtract these exponents, and 4 minus 3, is 1. And then the next set is the y's, and y to the 6th divided by y to the 4th will give me y squared. And this is going to be my simplified answer. We are going to have plenty of time in class to be looking at these, all kinds of examples, some simple and some more complicated. So what I'm asking is that you know these 5 rules: the power rule. Well, let's start at the beginning. The multiplication rule, the division rule, the power rule, the negative exponent rule, and the fractional exponent rule. And then we will practice.